Hello, welcome back to Structural Analysis Made Fun and Easy. So this is part 2 of problem 2.9. So this is quite a big problem actually. It took longer than I thought. So for chapter 2, linear analysis of frameworks, copyright T.R. Graves Smith and Ellis Horwood, publisher. Chapter 2, problem 2.9, part 2 video. So first of all, page 10 correction. So on the end of the last video, I'd put BC instead of BD, so we're working out the BD and the components, so BD, VBD, HBD. So this point here is just a marker point, B2 I call it, it's not a joint. That's just a 3 meter marker point. That is a joint there. That joint is D and this one's B. In this case obviously we can see that cos 45 should equal sine 45. So let's find HBD. So sine 45 equals, from that side, HBD over BD, as sine 45 equals cos 45. Also cos 45 equals HBD over BD. Sine 45 is 0.707, which is equal to cos 45. So HBD equals sine 45 BD, which is 0.707 BD. So from sheet 9 from the previous video, BC equals HBC over cos 26.57, which is HBC over 0.8994 equals 1.118 HBC. So HBC is equal to 0.98994 BC. So that's a correction to page 10. Moving on to page 11, HBD equals 0.707 BD and HBC equals 0.8994 BC. So we've got those two equations now. I think this might be solution of simultaneous equations, but I'll come back to that in the last part of the video. Solution of simultaneous equations, similar to that. So now we've got the HBD and HBC. We can solve the. We've worked out the component of BD and BC. Now we can work out overall internal. I can call it internal horizontal equilibrium because there's no external forces. So HBD equals HBC. Say substitute to find BD in terms of BD in terms of BC. So 0.707 BD from above equals 0.89994 BC, because HBD equals HBC. HBD is 0.707 BD, HBC is 0.8994 BC. Therefore BD equals 0.8994 BC over 0.707 equals 1.271 BC. So BD equals 1.27 BC. HBC must equal HBD. They must be equal but opposite. Sorry, I've messed that diagram up. I'm going to redo this, but it's just to show that BD was compression. So HBD is from left to right. That force must equal to HBC, which goes to the left because there's no external forces. So they must be in balance. So that the rest of the diagram, I'm going to redraw that, but that's just to show that then BC must be in tension. So now we can work out the vertical components of BD and BC, because we know we've got the reaction 13.33. That then we can find out now. Then we can find the equilibrium. Then we can find out the. Then we can find out what resolve the vertical components. We should actually be able to work that out fairly quickly. So this is preparation for vertical equilibrium. VBC. So this is BC over. Find out what VBC is. VBC, there's another little diagram. 26.5 sine 26.57 because VBC over BC. VBC was sine 26.57 over BC. 0.447 BC. So VBC is 0.447 BC. Then for BD, VBD, sine 45 is VBD over BD, VBD equals 0.707 BD as per above. I think that was a. So now we can do vertical reactions. Vertical reaction VBD equals VBD equals VBC plus 13.33. So use page 12. We've got 0.707 BD equals 0.447 BC plus 13.33 KN. From page 11, BD equals 1.272 BC. Use this in equation 10. Remove BD. 0.707 from above times 1.272 BC equals 0.447 BC plus 13.33 kilonewtons. 0.89789 BC equals 0.447 BC plus 13. So 0.89 minus 0.447 BC equals 13.33. 0.5089 BC is 13.33. BC is 13.33 divided by 0.54508 equals 30.56. Tension. So, actually, I need to do, in the third part of this video, I just need to do another little correction, because when we found out, once we found out HBC and HBD, because we know the angles, I could have found BC from that. So when I'm doing my closing check-in, I'm going to do a final check of the whole thing. I can come back. So I've double checked. What I've done there is I've double checked it. So when I come back over it again, I should find that that is 30.56 from the other side. BC equals 30.56. BC equals 30.56, and HBC is 0.8994 BC. And HBC. Yeah. So I'll come and finish that off. So there's a little diagram of what I've got so far. BC equals 30.56. BD1 is 1.272 BC, so that means BD is 38.872 kilonewtons. So I think I found two forces. That is BD 38.872, BC 30.56 T. So BC equals 30.56 and BD1 equals 1.272 BC. It was 38.872 kilonewtons. So I can check that again in the last part of the video. We can now do equilibrium of joint D. So diagram of forces are components at joint D. So we've got BD is compression in, AD is tension out, CD is compression in by, because if VBD must be up, so VAD must be down to balance it. So BD, we know that's compression, so AD must be tension because VAD is down. So that means, we start with vertical equilibrium. Because there's only one unknown, that is VAD. VBD minus VAD equals 0. VBD equals VAD equals sine 45 BD is 0.707 times 28.872. So it's 27.48. Sorry, it's VAD is 0.707 times 38.872, which is 27.48. 27.48. VBD, that is. VBD is 27.48, so that means VAD is 27.48. Now we can find AD and HD8, because AD is, the angle is 26.57, so VAD is 27.48. Cos 26.57 minus HAO divided by AD is sine 26.57 equals VAD over AD. AD equals VAD over sine 26.57, and HAD is cos 26.57 times AD equals 0.8994. Now we can find the horizontal. Now we can find CD, because we've got CD minus HAD minus HB equals 0. CD equals HAD plus HBD. Because this problem's taking a bit longer. Please can you tune into part 3. If you want me to put this video into one video, I might do that, but it's going to be quite long, but I can tidy it all up. Hopefully you can tune in for part 3 of the video. Thanks for watching. Please like and subscribe to the channel. See you in the next video.